Hello, everyone. Am I audible? Amazing. So, hello, everyone. Welcome to day two of the Winter Sprint Bootcamp. Today, we're diving into the software engineering tetrad, and we're gonna be understanding what actually makes a strong software engineer beyond just writing code. So, we'll be breaking down the four core pillars that basically shape real world engineering. And without any delays, let's actually get into it. So, a little about me. I think the majority are familiar. So, I'm an AI engineer and software developer with over 3 years of experience in the fields of applied AI, machine learning, and basically anything that's research driven system development related. I also hold a dual master's degree. So I did my first master's degree in computer science, and then I did another one that was more research focused in data intelligence. And basically, my work focuses on building scalable, production ready intelligent systems. And I'm also into graphs, graph theory, and knowledge graphs. Currently, I'm working as an AI research engineer as well as a software engineer. Alongside my industry work, I've also worked as a university instructor, and my most recent role was basically an instructor at RHU University. I basically mentored a lot of computer science students and a lot of future engineers. And beyond that, as most of you know me as, I'm the founder of Code with Sarah, which you're all here joining us here today. And over the last couple of months, we've grown into 1.5K community members. Um, I also recently did graduate from Oxford, where I did machine learning summer school. But today, I'm speaking to you not just from theory, but also from research, teaching, and real world system building. And I think the most of you got a bit curious about the title. So I'm pretty sure some of you tried checking or like, oh, what does she mean? What's that tetrad? It's the first time I ever hear of it. So it's not a known term, basically. But it's more a collection of like everything there is to know about software engineering and such. If you guys are interested, you can scan the QR code here and feel free to add me on LinkedIn. Also, as some of you requested, those are the socials for Code with Sarah. So you can scan them. You can add us on LinkedIn, Instagram, and also you can join our community on WhatsApp. And for any inquiries, feel free to contact us at this email. So, actually, fun fact, Code with Sarah was founded on Ada Lovelace Day, which was October 13th. And basically, she's the woman that wrote the first computer program. And just so it happens today, today is the International Day of Women and Girls in STEM, and I'm a women in tech and women in STEM advocate myself. So here we are with today's session. Now, enough with the formal definitions and such. I'm pretty sure a lot of you here are joining us, wondering where is Elmo? He's here, joining us, and is excited to learn more about what Elmo has been doing for the last couple of months. Feel free to just type in the chat box. Weird, seems like no one's excited. All right, so shall we start with the story time? Yeah, he could be drinking tea. All right, so here's what happened. So ever since the previous bootcamp in summer, Elmo has gone on a very, let's just say, rough adventure. So he has been trying to get into the AI industry after he cooked at the latest AI bootcamp. And unfortunately, he has been struggling a lot because he had quite some misconceptions about the field of AI. So, as we can see here, you all recall from our opening ceremony that he has gone on an accident and broke his leg. But we didn't really talk about how did that accident happen. Anyone has any guesses? No guesses. Yeah, poor Elmo. So we all know Elmo loves AI, right? He really does. So what happened was apparently Elmo's only good at building AI models, but unfortunately, he doesn't know how to actually apply them in the real world or actually scale them. No, not a car accident. Not a climb accident either. Dog crossing the street on the wrong time, definitely not. So he was skiing in the North Pole, right? He loves AI. So he thought that, I'm skiing, this mountain is small. So far, so good, right? Until he went on a, let's just say, a harder part. Like he skied there and it was something that he wasn't prepared for nor trained for. And unfortunately, what happened is he broke his leg. Yeah, something definitely went wrong, and as we can see, he went and broke his leg. But luckily, we have our character for this sprint, Pango. Pango came to the rescue for sure. Don't worry, Almo's is still there. However, he's getting some assistance from Pango. So we have Elmo, who's an AI ninja, And Pengo, as you can see him here, he looks like Batman, honestly. He's a superhero. So he saved Elmo and is helping Elmo get his motivation back and get back right on track. So he's a software engineer ninja. So as we can see, Elmo is into AI and Pango is our software engineer ninja. So over the upcoming few days, we actually have a session tomorrow, and then we have the last day of the boot camp on Sunday. We're gonna dive into SWE related sessions, and they're all gonna be by Pango. So I'm pretty sure that you're all gonna benefit a lot. And we do have a couple of AI sessions. However, I want to emphasize that AI today isn't what it has been like just like three years ago. We're moving into a very fast paced era, and you cannot just get into AI, at least in the current market state, without having all of the software engineering fundamentals. And this is why we actually went with this theme for the bootcamp. So it's both theoretical and hands-on. And we also have got like a couple of surprises, which we're gonna be basically announcing on Sunday. So I'm pretty sure you don't want to miss the sessions on Sunday. They are very intense, however, they're really exciting. And today's session is gonna basically set the stage for the upcoming sessions because this is all what perhaps the theme is about. So, like, we're gonna be wrapping up everything and that you need to know about software engineering in this session. So, make sure to grab a cup of coffee and have fun. All right, so enough side jokes, enough of breaking the ice. Let's get into the real work here. So, today's session is about the software tetrad, and when we speak about the software engineering tetrad, we're mainly talking about four aspects. So, those four together, they all come together. You cannot separate one from the another. And some people might perhaps be good at a certain aspect than the other. It depends, but it's all about how you make everything basically connect. So when we're speaking about the tetrad, we're basically speaking about programming, soft skills, design, and architecture. Those four come together. And we're going to be talking about all four of those in today's session. Now, you might notice that couple of those we've already discussed and talked about earlier. So I'm just going to go over them really quick. Now, when we speak about programming, I'm pretty sure everyone here knows programming, or at least you have some knowledge, regardless of your background, if you're a beginner or advanced, and regardless of like what major you're in or like what CS year or engineering year you're in. When we speak about programming, this is the foundation. And basically, in today's era, some people are basically getting into tech just for the sake of vibe coding. Like, obviously, you cannot vibe code anything without mastering the syntax, the basics, the problem solving mindset. So you need to have the ability to think logically, have problem solving skills, because it's not just about syntax. I can go to Claude and I can just ask Claude to vibe code something for me. Like, it does it and it does it really great. So it's not about learning the syntax, but merely about problem solving. And there is a couple of platforms like LeetCode. I think my latest students are traumatized from LeetCode at this point. Some of them are here joining us, I guess. But LeetCode is the key to master problem solving and basically the mindset that you need as an engineer. However, you need to go with it like carefully because you don't wanna memorize the patterns or the problems nor the syntax. You wanna work on your problem solving skills. They help basically they help prep you, train your thinking patterns, edge cases, as well as your ability to optimize. Because us as engineers, we're often obsessed with optimizing. There are a couple of other platforms, but personally, LeetCode is my favorite. And fun fact, I actually have a 3 year and ongoing LeetCode streak. So I haven't paused on solving LeetCode since like 3 years, and I'm still going. So it's a good habit, and I encourage everyone to basically just go and sign up and create an account. However, you need to be very mindful of how you basically use it and how you utilize it. Now we're moving into the other aspect, which is soft skills. And I would like to just basically make a couple of notes here. Um, so earlier we did the pre-winter sprint. It was last month on January the 24th, and it happened to be on the International Day of Education. So in that, it was a mini 1 day boot camp. We focused on the soft skills aspect. So if you're interested in basically watching that, you can feel free to scan the QR code or basically just check out the playlist here on our YouTube channel, and you can rewatch all of the session. So we focused on communication, collaboration, confidence, and basically how to build your professional brand and professional identity. And definitely, soft skills is an important aspect, and you shouldn't miss on soft skills, regardless of how good you were. If you don't have the right soft skills, if you don't have the needed soft skills, how to communicate, how to collaborate, how to work in teams, how to pitch even, and like some public speaking skills, emotional intelligence and such, you won't be able to basically do as great as. I believe I got disconnected. Am I audible again? Awesome. So sorry about that, guys. Wi-Fi issues. Welcome to Lebanon. All right. Let me reshare my screen. Please let me know which part was I. Which part did I stop at? Just to recontinue from there. Awesome, awesome. Let us resume. All right. So we were speaking about architecture. So we've talked about programming. We've talked about soft skills. Those are important aspects. Now comes the heavy stuff, and we're going to be talking about architecture. So when we say architecture, does anyone have any idea what does architecture means? Come on, guys, feel free to drop in your answers in the chat box. Don't feel shy. Awesome. We have an answer. Constructing. What else? Let's see who's collaborative. Come on, guys. Feel free to drop in your answers in the YouTube chat box. All right, we've got a couple of great answers actually. Some of them are GPT generated, but that's fine. All right, so now I'm gonna want you to basically have a clear look at this slide, like a deep look, like try to think. We have books and we have an exam paper. What do you think we're talking about here? Let's take some answers as well. Let's see. So I was just getting started with architecture, right? And now we have a slide and we have a couple of books and some exam papers. What do you think I'm talking about? UML designing. Oh no, my dear, we're not diving into that today. Okay, I see a very smart comment here. So Rawad is mentioning the way file and folder of a project are arranged. Okay. Hamid is also mentioning it's all about components, data, and models. Okay, cool. Preparing for an exam, lecture, or grading. Okay, let us take this case scenario. So, when we have an exam, all right, I'm sure you're all here either in college or you're still a high school student, probably, or you even graduated from school or college or whatever. So I'm pretty sure we've all been traumatized by exams, sometimes even pop quizzes and such. So some of us used to basically study the very last minute. I believe I would say 99% of students still do that. Others perhaps had a well structured system to study or to prepare for an exam. And I also noticed a pattern. I noticed a pattern that usually happens to happen a lot A lot of students go and practice on previous exams, and basically they try to memorize and understand the pattern. Some prefer to just understand the theoretical aspect and, challenge themselves in the exam without the questions prep or anything. So, what all of those have in common is they have a plan, they have a structure, a system that they all follow to get a certain outcome. And not every system or structure is the same. Some are better, and this is why we have an A plus student and let's just say a C plus or a D a student. So the way you build your system or structure it matters, and this is what basically differentiates a good system from a bad system. So now that we've got that in check, let's move into defining what an architecture is. So essentially, an architecture is the big picture system decisions. It's all about the decisions that you make in order for you to, let's say, prepare for the worst case scenario, prepare for complexity, prepare to be challenged. And it often keeps things organized. So as our system grows and gets even more complex, we need to have a well architectured system, right? With clear boundaries, responsibility. And if we don't have that, collaboration is going to be tough. So, with a well architectured system, collaboration and working with other people is going to be much easier. Now, I'm going to ask you guys a question. So, we're living in the era of AI, and a lot of people are currently vibe coding. Some are doing it right, some are doing it wrong. It depends on the person. Now, I want to ask you guys, who here have basically worked with someone who writes bad code? Like in a group project or something at uni. I'm pretty sure we've all been there. Personally, back in college, I've been there as well. Feel free to basically drop how your experience was. All right, I'm seeing a couple of answers. They made me do the whole coding. Yeah, this happens a lot. I've worked in a team that wasn't that much cooperative. That happens a lot. Anyone has, yeah, of course, Mehdi. So I was saying, who here has worked with a team, perhaps colleagues or people in your class, and they wrote bad code, or you basically struggled, let's say. Okay, I'm getting a lot of answers. I'm kind of that person right now. Someone named Frost. I'm just gonna say you need to work on that first. That's not cool at all. So I'm pretty sure we've all been there. And lately, it's been going on like even more and more. And believe it or not, it's even happening at companies. So basically, a lot of, let's say, junior software engineers or junior AI engineers, when they join a company, they just basically they tend to vibe code a lot. Now, I'm not saying vibe coding is a bad thing, but it would depend on how you use it because you obviously cannot do everything with it. And as you've seen with yesterday's session with Perla, she explained to you how shall you use it. Like you shouldn't fully depend on it, right? So right now, with the hype of vibe coding tools out there, junior engineers are basically just destroying systems and such. I mean, there are a couple of stories that are crazy. Some people deleting the entire company's database and such. The stories are really crazy and they're actually funny. Now, this goes back to the bad usage of basically vibe coding tools out there. And if you're basically building a system or building an application, okay, and from the start, it's vibe coded, it's basically all spaghetti code that cannot scale, that's super bad. Like, if you're working with someone else in the team, you might do some changes and then the other person might struggle to basically stay up to date on those changes because usually with AI out there and vibe coding tools out there, it really makes collaboration tough. So it's often extremely hard to vibe code and have a scalable and a well articulated system. Which brings us to our point: architecture first, design first, system first, and then comes the coding, between brackets, I'm gonna say programming. So having a great architecture of your system and such is extremely important, and it all comes down to the decisions you make. So what are these decisions actually about? Like, sure, Sarah, you're talking about decisions, but what do you mean? So the decision actually starts from the moment you select your tech stack. And what I mean by tech stack is basically, I'm gonna say, technology choices, like basically what programming language are you using, or like what library or what framework. I noticed someone is mentioning what is vibe coding, but some vibe coding is basically just go hop into ChatGPT and tell it to generate a code to solve a problem or something. Okay, and just take that code and like keep prompting GPT or any LLM out there. So this is what vibe coding is about. Like you building programs and applications via LLM tools out there. So you're technically not writing code, you're just prompting. And you might do some context engineering as well. It would depend, connect some tools and MCPs and such to have better and more accurate results. I hope that's clear, Bassam. So it starts with the technology choices that you make, the system structure, how you structure your system, data, and how everything in your system is gonna communicate. How can you scale? How can your system be reliable? Security choices, as well as deployment and operations. Just a quick heads up for the deployment and operations, this and security as well. This is what basically the emphasis of tomorrow's session is going to be about. So you don't want to skip that because tomorrow's session basically builds up on my session. So make sure to tune in tomorrow. All right. So when we talk about architectural decisions, this is what we're essentially talking about. All right. Now, don't get scared, guys. This table is, let's just say, includes a couple of examples. It's not scary, but I'm just gonna go over those real quick. So we have the source control, CI/CD, cloud, structure, backend, frontend, data, observability, security. And quick heads up, the observability, security, source control, CI/CD, we're going to be tackling them tomorrow. So regarding cloud, we're not going to tackle deployment and such in this bootcamp. But we have an exciting surprise. It's going to be announced later on Sunday. Backend and frontend, we have a couple of frameworks to use, and each framework would depend on the problem you're tackling, what are your goals and such, before like actually making that choice. And we'll also have a front-end session on Sunday as well as a back-end session regarding the data. So data is basically the currency right now in our era and in the upcoming few years as well. We have several types of data actually. SQL, NoSQL, so there's plenty. We're not going to be diving into data today. That will be for Sunday. But the purpose of this diagram is just to show you that those are some decisions you're making from an architectural POV. Like whether you're using GitHub or GitLab, this is a decision. Whether you're using Jenkins or basically GitHub Actions, this is a decision. Whether you're deploying on GCP or AWS, this is a decision. Whether you're working with Node, Express, or the Django or Fast API, this is a decision as well. Whether you've chose SQL or NoSQL, let's just say PostgreSQL, SQL, or basically MongoDB, this is a decision as well. So we have a lot of decisions to make as an engineer before actually getting started with the coding part. You don't have to memorize that, by the way. This is just an example. So, someone hopped in. Never mind, I just want my leg to stay broken. So apparently, Elmo is not so excited about making decisions. Zero, you mean decisions among teammates to plan something? No, not really. This is just one part of it, Zero. There are other aspects, and we're getting there. So today's session is a bit heavy, but it's really exciting. So let's just say you're building a project, okay? And sure, when you're practicing on your own, building a project, a solo project, everything looks easy. When you don't have to worry about deployment or how many users it's gonna have, everything looks easy. But what happens when that system gets complex, when you need to scale? Like you might not notice the importance of making a great system and taking those architectural decisions that we spoke about here. Because when you're working solo or when you're basically, building some projects and such, that might not have an effect. But when you need to go live, when you need to market your product, when you're working in a company, you need to basically take note of those because it is extremely important. We don't want to basically, let's just say, be like Elmo, right? It's okay, Alma. I'll make decisions for you. That's great, Khalid. So, what do they look like? So, this diagram is basically as a software engineer. Don't get shocked, guys. It's not that complex. We're gonna be tackling a bit of it today, so don't get shocked. So I was saying this diagram is like, as a software engineer, if you don't understand this diagram, then you're not doing good. All right. And I tend to notice currently nowadays in the market, a lot of software engineers are weak. They lack the basic skills that are needed. And they rely heavily on vibe coding tools out there and miss out on the bigger picture. All right. So if you don't know this, then don't worry. We're going to be tackling it today. For sure, not all of it. Actually gonna stop a bit towards the event hub, and we're gonna be resuming the rest on Sunday because it's quite heavy and tense. I know, but after today's session, you're gonna have a different, let's just say, vision or POV about software engineering. I'm pretty sure that's everyone's reaction right now. Who got scared from this diagram? Feel free to drop in the chat box. Or who is familiar with at least some parts of this diagram? Like, if you understand this truly, then you understand all that is to know about system design and architecture and such. Okay, so no one. Okay, I guess we have couple of beginners in today's session. Come on, guys. Is anyone familiar with what an API is? Both ways, no worries. We're just gonna be going over them. Okay, we have someone, Hannah. Okay, I did, but somehow familiar, as you mentioned. That's great. Who else? Come on, guys. Don't be shy. All right, that's cool. Stands application programming interface. Okay, that's good. Yeah, you can consider it as such. Okay, so that's great. Phil, couple of people here are familiar. This is great. So we're gonna be tackling this, okay, step by step. So as we move forward, it's gonna get complex, but it's important to understand each step by step. All right. And if you recall the tetrad that we started with earlier, we had programming skills, architecture, and design. So the thing about design is it is already a part of the architecture. So you can say it falls under it. Like the waiter in a coffee shop. Yep, though those are a couple of great examples. So I'm posing guys a bit just to read your comments and answer them on spot. All right, so let us get started with the very first part of that scary thing that you guys saw earlier. All right, so first off, we're starting with a service pattern. Now, I'm pretty sure that some of you, well, maybe not all, have worked with a DB before, fiddled a bit with it. You guys, some of you guys here are familiar with what an API is, which is cool. So, what we have here is called or often referred to as a service pattern. Now, some of you might have been like doing this or like using it, but maybe let's say you're not familiar with the name, which is all right. So, what is a service pattern? Really is. Let us basically start with this is one of the most fundamental architectural patterns out there, by the way. Like, this is pure fundamentals, let's just say. So, to simply put it into definition, okay, what we do here in the service pattern is we separate the system into three main components. We have the client, all right. So we have the client here, as we can see. And we have the API layer and the database. So the client usually handles presentation and user interaction. So it's whatever you're interacting with. And the API layer contains, let's just say, the business logic, the validation, the communication, what's needed basically. And then we have the database. And the database is where you're storing the data, right? So it is often responsible for the storing state. Now, it is extremely important to note that the client doesn't communicate directly with the database. All of the communication goes through the API layer. This is why when you're getting started with backend and like, your journey with getting started with backend and such, you download Postman and basically get started and, building your own APIs. Some of you might even find that a bit hard. So you perhaps start using ready APIs and such. So APIs are extremely important. But why do we separate them this way? So it is extremely important to note that this separation enables, let's just say, security, more control, and more structure. Because here, as you can see, every layer has a clear responsibility, which brings us back to our first point. Okay, we need to make decisions about responsibility. So if every layer has a clear responsibility, then our system is clear, right? And if our system is clear, this brings us clarity. And if we have clarity and clear system, we have a maintainable system, right? So this is how we can basically sum up the service pattern as. And this diagram here basically focuses on the communication flow, like who's talking to who. All right. Now we're gonna be moving into, let's say, I'm not gonna be moving into anything. I'm actually gonna just try to twist those a bit and refine it a bit. Okay, what do we have here? So the earlier slide, we had the client, the API, and the DB. And here we have the DB, okay, the database, the API, and the client. That's weird. Are we still in the service pattern? Well, what we did here is we just refined the perspective a bit. So instead of us focusing only on the communication flow, we had a look at the system boundaries. From the client perspective here, okay, us as a client, we're here as a client, like from the client's POV, okay? The backend is basically a single cohesive system, right? Because me as a client or anyone out there, okay, using your system or application, okay, they don't know whether we use one database, multiple databases, caching, layers, eternal services. All of that complexity is hidden behind this like this table. I'm gonna say, or let's define it as this boundary that we're seeing here. All right. Now, okay. Now, what do we have? So everything inside this boundary belongs to the backend, right? And everything outside this boundary is an external customer, which is the client. But here is a very important point. Even though the client does not directly communicate with the database, we still have some indirect coupling. Like, for example, let's just say we need to upgrade the database. Upgrade basically just means updating, okay? For example, we need to do some driver updates, okay? So we need to update the database, all right? In this case, our API layer might need to change. And if those changes basically affect the API contract, okay, the client will also need to adapt. So essentially, separation here reduces coupling. But we reduced the coupling, right? But that did not eliminate dependency. So it did help us control how changes propagate. However, it did not eliminate basically, dependency. All right? Then how can we do that? I don't expect you guys to know the answer. So let's dive into another part. So right now we're just building a puzzle here, okay? That at the end of this session will connect to the bigger flow. All right? So just keep on listening and stay curious. All right? So now we're moving into telemetry and observability. All right? So we've discussed the structure, the clear boundaries. Now we're gonna be introducing something as critical, which is observability. Okay, my system works. So what? You think that's the end game? Like, okay, yay, it runs, it works. Do you think that's the end game? Obviously not. So a system is often not complete simply because it works. It is complete when we can monitor it, measure it, and basically understand it. This is why KPIs exist, guys. Okay? So what we have here in this diagram is the same architecture, all right? Client, API, and database. But we've added another layer, as you can guys see here. We've added this layer, all right? Which is all about the logs and metrics. So every component here in the system, okay, emits telemetry. The client can generate metrics, the API produces logs and performance data, and the database exposes metrics about, your queries, your latency, and even your resource usage. And essentially, okay, this is what observability means. It means that we have the ability to understand the eternal state of a system by examining its outputs. And we often, when we need to ship into production, we cannot just risk failing or perhaps breaking things like Elmo, right? So a failure is definitely not an option. Okay. And without telemetry, we're often blind. Like, how can you trust something if you don't know if it's performing well or not? If you don't know where latency is coming from? If you don't know why your requests are failing? For example, I'm trying to log in and it's giving me an error. I cannot do anything. Why my requests are failing? Or if we don't know whether, let's just say, our database is overloaded or not. So it's not only about how components communicate. No, it's also about how we monitor them and basically operate them. So this is an extremely important aspect, and you're going to be diving more into detail of it tomorrow. So far we've talked about the service pattern and such, and we've also talked about telemetry and observability. Now let's twist things a bit and change things a bit. Now we're moving into what do you guys notice? What did I add here? I changed some stuff. What do you think the read and write is about? Without GPT, guys. Have a lucky guess. All right, zero. That's cool. Operations. All right, all right. So we've discussed structure and boundaries. And what our service pattern did is that it treated the API as one unified layer. Now, sure, that works, right? But in real systems, all right, not all operations are the same. We cannot basically just have that in like real systems because it's not a one size fit all right? So not all operations are the same. So we often have two fundamental types of operations, all right? I noticed someone mentioned operations, Heba, I believe. Great job. And someone also mentioned read and write. Let us actually define what read and write is, all right? So the write operation often modifies state. So anything that changes the state is called a write operation. You can create data, update data, or even delete data. For example, let's take an example. I'm creating a user, all right? Or whenever you're shopping from Shein, for example, who here is a Shein addict and his or her credit card is currently struggling from their shop addiction? Feel free to drop in the chat box. I believe a lot of girls are gonna relate. All right. So, for example, when you're placing an order, this is a write operation. All right. Now, what about read operations? Read operations retrieve the state. So basically, what it does is it doesn't change anything. All right. It's a very chill person, okay? It doesn't change anything. It only fetches the data without changing anything in it. For example, when you're viewing a website, okay? Uh, viewing the products on a website or something. Or when you're checking your Netflix watch history, in case you guys are not familiar, you can actually do that. You can check when you started watching a series and such, and you know. So this is a read operation. And the difference is reads are often frequent and they're really frequent, and writes are critical. So in most systems, the majority of systems, the read operations happen like far more often than write operations. I mean, it makes sense, right? Because we're humans, and us users, we're visual creatures. We need to view stuff and such, right? Like you view products, the world around you, and such. So basically, viewing, all right, which is we're talking about the read operations, it happens more than write operations. And we're all addicted to social media, of course, and some of us even have brain rot at this point, especially Gen Z. So when you're scrolling and watching some reels on Instagram, this is a read operation. You're just viewing those, right? And we tend to notice that read operations need to be fast and scalable because they happen a lot. So they need to be fast and they need to be scalable. But on the other hand, the write operations, they need to be consistent, they need to have integrity. And of course, we cannot transfer money if we don't if we lack those, if we lack integrity and consistency. Okay. Now, instead of treating reads and writes the same way, because we've said that read operations tend to happen more, so we should treat the read operations and the write operations in a different way. Okay? We basically separate them logically. As you can see here in the figure, they both are separated. Okay? This is what we're talking about. That's us here. Okay? So they're separated. All right? And as you can see, okay, we have one path for write operations where data is often modified and where perhaps we do validation and such, and another path that's for read operations, and that's for when the data is queried and basically optimized for performance. All right. Now, the client can interact with both paths independently. And what we're doing is we're not necessarily changing the database itself. We're only changing how we structure responsibility within the system. So, I'm using the term responsibility a lot. We're back to responsibility, right? So, responsibility in a system is extremely important. Every aspect has a different responsibility and such. All right? Now, when we separate those, we gain better scalability, clearer performance, and even strong control over consistency. And this is how it is often. Now, what I've been yapping about for the past couple of minutes is actually called CQRS pattern. You might have used it before, okay? But you might not know the name. For those of you that know it, congratulations. It's often referred to as command query responsibility segregation. So it is extremely important, guys. And what I know the name might seem a bit scary, okay? We've just described it actually. All what I've been yapping about is basically just describing this in the previous slide. Now, I'm gonna be taking a quick break and I'm gonna be doing some pulse check here, guys. We're not taking a break from the stream. Don't worry. We're taking a break by asking you guys questions. Okay? Let's take a quick case scenario, all right? Let's say we have, if one chef handles cooking, okay, who would handle serving thousands of customers? The chef is responsible for cooking, right? But who is responsible for serving the customers? This should be an easy question, guys. I'm pretty sure the answer is pretty straightforward. How many waiters do you think you need? Okay, I've seen a couple of answers. How many waiters do you think? That's a very great movie, Star Guys. Can we know? Do you guys have a definitive answer of how many waiters? It depends. Yes, that's correct, Ahmed. It really depends. So we need to scale because we have thousands of customers, right? We have one chef. The chef is gonna be busy cooking, right? It's not gonna go and basically serve the people or share like food with the people in the restaurant, right? I mean, it might happen from a time to time, but like when you're like in a big restaurant and there are thousands of customers, of course the chef or the chefs cannot do that, right? We need waiters, right? Like a lot. So what you've just answered and what I've just described is basically you scaling the serving layer. And what do you think I mean by that? Scale. We've been talking about scaling a lot. No, Star guys, not 100 for sure. You cannot have a definitive answer. The answer is no answer here. It would depend, right? Yeah, exactly, Yana. It depends on the restaurant. So, what do you guys think scaling is? We have one chef, the chef Cox, okay? Uh, that's our right path, right? So, cooking is writing, right? Because you're adding ingredients, adding salt, pepper, mixing stuff, adding more cheese and such. That's your right path. Okay, recall the right path that we were talking about. But serving the customers, that's actually reading. So if we have thousands of customers and per se they're asking for the menu at the same time, of course we cannot go and duplicate the chef himself. Like, okay, you can add more chefs, but like, can they go and like serve people? Do you think it's convenient to basically duplicate the chef? For sure not. Right? So what we need to do is we need to duplicate the waiters. So we need more waiters. And this is the same when it comes to real systems. So when you're working with distributed systems, you don't duplicate the writer. right? You only duplicate the readers. Okay, so this is extremely important. Like, I'm pretty sure some of you are familiar with what the term distributed system is, or you've probably heard some people yapping about it on LinkedIn, right? So, in distributed systems, we don't duplicate the writer, which is our chef here. We only duplicate the readers, which is basically our waiters here. And that brings us to the replica pattern. So this is known as replica pattern. Some of you might have heard about the term, some of you might not be familiar. Regardless, what I just described is essentially the replica pattern. All right? So let's go to the next slide. Out of what we've just talked about, what do you think the replica pattern is, guys? Let's see who's been focusing. Seems like no one, so I'm just gonna skip to the next slide and we're gonna basically tackle this together. So we've explained how the replica pattern works, right? Now let's tackle this. So what do we have? We separated the reads and writes logically. How did we separate them? Using CQRS that we've talked about, right? But just separating them logically, okay, logical separation per se, is not enough when it comes down to traffic growth, right? Like if your traffic grew, okay, talking about our DB, if we have a lot of traffic and if our traffic grew, okay, we have an issue, right? And logical separation merely is not enough. So what we have here is a primary DB, a primary database. And this primary database is the source of truth. So this is where all of the write operations go. And when we create data, update it or delete it, it happens here, okay? It happens in the primary DB. All right? Now, why do you think we did that? Like, okay, they're happening in the primary DB, but why? It's because write operations, writes usually need a lot of consistency. Okay? But okay, you're talking about consistency, but like, why? Let's have a look at the replica DBs that we have here. Okay? So, what about the reads? Reads are usually much more frequent than writes, right? So, let's say we have thousands of users and they're trying to refresh the dashboard, load their Instagram feed to basically just watch some reels or querying data or such. We don't want to be constantly hitting the primary database because we have a lot of write operations, right? There is write operations, they're happening in the primary DB. We don't need to be adding to that, adding traffic and also, doing some read operations and such. So what we do is we introduce replica DBs. This is what we call them. And they are basically just replicas. And what a replica is, a copy, like, you know, the process of replication, making a copy of something. So a replica is a copy, okay? So those replicas are basically copies of the primary DB that we have. And of course, they receive data from the primary DB, and they're the ones that handle the read traffic. Now, what this does is it allows us to scale reads horizontally. So let's say the read traffic doubles. We don't upgrade one machine, we add more replicas. Okay, so we keep scaling and adding more replicas as our traffic grows. This is why we call it the horizontal scaling. Okay, and this is the flow that we would have. So the client writes, all right, me as a client, I did a write operation. It goes to the primary DB. The primary DB propagates the data, then it goes to the replicas. The client reads the replicas, right? Let's see who's following up. Awesome. So we got some people. Okay, meta data centers. That's cool. Yeah, that's correct, Hassan. I'm gonna answer this at the end of the session. All right. I'm gonna be basically answering it in the next slide probably. So stick here in the stream. Okay. So the client reads from the replicas. Now we have something extremely okay, that happened, that's the flow, but we have something extremely important. So data in replicas is eventually consistent. So often, okay, of course we cannot have everything perfect, like there's no such thing as perfect. Often what we mean by eventually consistent is that there is a small delay when the data is written to the primary and when it appears in the replicas. And like it's very small, like, okay, computers notice it, but us as a humans is like barely a second, even much less than a second, in split seconds. Okay. So let's just say I want to write something, okay, and then immediately read from the replica. We might not see it instantly. However, like you would, but like, you know, couple of seconds, in a split second or so. Okay, and that's okay for many systems, such as social feeds, analytics, dashboards, product listing, and such. That is okay. Like I'm pretty sure you're all like haven't noticed that whenever you were like, you know, scrolling and watching reels on your Instagram feed or TikTok even. They don't need perfect and immediate consistency, okay? But, okay, sure, in those fields it's not critical, right? But when does this, let's say, becomes crucial and critical? In critical fields, for example, when we're doing banking transactions, okay? It's a whole different story there. Okay? I'm just gonna leave you with this thought. It's a whole different story there. We'll see a bit in a few. So, essentially, replica pattern is all about scaling reads physically, protecting the primary database, distributing the load, and also accepting eventual consistency as a trade-off. Now, the CQRS, separated responsibility logically, and your replica pattern scaled it physically. Okay? This is what we basically did. Now, let us add some more services. Okay? And let's see what would happen. I hope it's clearer now, Zero. I can always go back to the previous slide if you guys want, all right? I think it's clearer now. We're just walking through this step by step. And I think the session was supposed to be till 8:30, but no worries. I'm just gonna take a couple of more minutes. We're not gonna wrap up this session today for sure because it's part one. We're gonna be resuming part two on Sunday, so don't worry. We weight users and then we replica patterns based on the need. I'm still lost. Zero, kindly type in your question or what's not clear about it, okay? So let's add more services, okay? And what we mean by services, notifications, shipping, analytics, payments, and such, okay? Okay, thank you, Khalid. Okay. Zero, please type in your question and I'll try my best to answer it as smooth and easy as possible, all right? Okay, so now we want to add more services. Why do we do that? Because, of course, a business often grows. Perhaps you need to add more users, your notifications, shipping, analytics, payments. So when we think of adding more services, the problem stops being entitled to only database scaling. It's not database scaling anymore. Okay? We had one giant service before. Let me go back to the previous slide. Okay, we have one giant service. Okay? So if we want to add more services, the issue stops being about only scaling databases. Okay? We start with responsibility scaling. Notice how many times I've mentioned responsibility throughout the session so far. So it is extremely important. So instead of having one giant service, we basically split it into payment service, notification service, shipping service, merchandise service, etc. We just split the services. And each service has its own API, its own DB. Now, I'm talking about services here. What do you think I'm talking about? What did I just describe? I'm pretty sure that a lot of you have heard about this before, but perhaps you didn't understand it clearly. We have a lot of services. We're talking about microservices, right? Yes, that's correct. Great job, Khalid. Guess we have a star for this stream. That's great, Khalid. You have great answers. Ahmad too. So we're talking about microservices here. So we're just entering the microservices territory. Okay? Now, let me move into the next slide. Okay, I think we're gonna stop at slide. We're just gonna take a couple of more slides and we'll resume with part two on Sunday. Okay, this is part one, but like we resume, okay, a bit of towards the end of part one, and then we'll get started with part two. Okay, and I promised you by the end of this session, you're gonna be just like Pengo and SWE Ninja. All right. So, what are we looking at here? What do we have? We have a client, and oh, we have a lot of services. So, we only have been working with optimizing one service before, okay? Yes, we separated the reads and writes. We introduced replicas for scaling reads. That's cool, right? Am I still audible? Yeah, okay, awesome. So that's cool, right? Now, real systems often they don't stop at one service because as you can see we have a lot of services here. So when you're building a real product, you just don't have one API and one database, that's for sure. We have one for payments, orders, merchandise, user management, maybe notifications, analytics, and each of those becomes its own service. And you should notice that each service has its own API, its own database. And the reason is because services should own their data. All right? Services should own their data. And this is how we move from a single system into a distributed system. Okay? And now we started with distributed systems, right? But actually, this is where the complexity often starts. So it's rarely ever talked about. You don't see anyone talking much about that. Okay? Now let's do a quick pulse check. Meanwhile, I will be checking your comments, guys. So those are all different pasta types, okay? Or spaghetti or whatever. Which one of those is your favorite, guys? Feel free to drop in the chat box. Awesome. Many people have different types of pasta. Khalid, no, you weren't wrong. It is microservices here. Okay? Mariam is asking. So if 1,000 users trying to read from one prime, oh no, that's not it, Mariam. Okay, I'm gonna get to Q&A at the end of the session, so don't worry, guys. Okay, so okay, a lot of you have different types. Okay, cool. We're talking about pasta here. Okay, we're all talking about pasta here. Okay, so it's a long session, right? We're gonna wrap up in a few, don't worry, guys. So, the reason I've asked you guys about pasta is for this exact diagram. Okay? Now, we're moving into architectural trends and we're gonna go more in detail into microservices and such. And I believe we're gonna stop here for today. We'll resume on Sunday, okay? I feel it's a bit heavy session on you guys, but no worries. So now we're moving into architectural trends. All right? Just pulse check, guys. Feel free to comment or interact just to ensure you guys are still energized. So when we talk about architectural trends, I mean, look at this. This is just beautiful. It started from the late 90s, before we were even born, right? So it definitely didn't happen overnight, okay? And we kept evolving, okay? Like we're constantly evolving. This trend, the architectural trends are constantly evolving, okay? So, first off, in the 90s, we had what we called spaghetti architecture. It is like a junior software dev that doesn't know how to vibe code. I'm just gonna go ahead and call it that, okay? Because it's spaghetti code. All right. So in the spaghetti architecture, it's literally just a mess. You copy and paste everything, and it is a mess. Okay. So everything is connected to everything. Very, very, very hard to maintain. Extremely hard, and often it has like tight coupling. Okay. Now, of course, we couldn't last more than 10 years this way. So, what we did is in the early 2000s, we basically started layering things. Okay. So, we layered things. We had a presentation layer, business logic, database layer, and such. Okay. And that was good. Okay. But it wasn't that clean, really. Then in 2010, we moved into microservices. And we just talked about microservices a couple of slides back. What microservices really is, okay, just small independent services. Each service has its own logic, own API, and its own database. Okay? And that's what we're building here. Okay? But microservices introduced problems as well. Okay, it introduced a couple of more problems. We're not gonna talk about the problems today. I'm not gonna end it or maybe try to brainstorm what possible problems microservices might have caused. But we're not talking about that. Then in the couple of I'd say 6 years ago, we also moved into the serverless architecture, which is also called Risotto architecture. Okay, so the names are easy to memorize. They're all just different pasta types and such. Okay, so what I'm gonna be doing on Sunday is we're gonna be continuing, okay, with the problems that microservices have caused. Okay, and how do we tackle them? How did we tackle them? And then in part two, we're gonna be diving into design. All right. And then we're gonna wrap everything up and just, connect the dots and everything. And, the biggest main takeaways and such. So I believe this wraps up the session here, guys. And I hope you guys have enjoyed it. Make sure to digest it really well. You can rewatch the stream, by the way. It's recorded. It is found on YouTube. You can rewatch the stream and, just digest the thoughts and such, okay? So I'm going to end here and I'm going to take Q&A. If anyone has any question, feel free to drop in your questions, guys. Okay? No questions. Okay, I believe people are hungry. This slide made you guys hungry, right? Yeah, I definitely recommend rewatching the stream because we had a lot of information, very important information, and I hope you guys enjoyed the lecture. This is part one. I would say 75% of part one, actually. We're gonna resume on Sunday. Okay. We're gonna resume on Sunday. And if you guys have any questions, please feel free to ask. All right? Not food related questions though. Please, guys. Okay? Not food related questions. Okay, I'm gonna just stick here for a couple of minutes in case anyone has any question. You guys can hear me well, right? Okay, let me see if there are some questions. I noticed some of you guys were asking me questions during the session. Please feel free to retype your questions again. Okay, you're most welcome, Mahdi. I'm glad you've enjoyed. So right now we are moving to serverless architecture. Yeah, we're gonna have to dive into some stuff, and then yeah, we're gonna move into serverless architecture. And don't worry, we're gonna dive into that. Okay, zero. Okay, there is a question. Yeah. Okay. API is like the interface that the users see and use its functionalities, and this functions by communicating with the DB and making demands. Um, not exactly, because API is not what the user sees. Okay, so you as a user, API is not what you see. Okay, what you as a user see is basically the client. So it could be the website or the mobile app. Okay. And what happens is an API is your middleman. Okay. So an API is your middleman, and basically from its name, it sits in the middle. Okay. You can think of it like let's just say you're going into a shop. Okay. So for example, or a company or something, or you're doing an interview. Okay, you just enter the company or whatever. Okay, and the client, what you're seeing, okay, is the person at the front desk. Okay, and the API, okay, the person at the front desk is basically secretary. Okay, so who's on top? Who comes like on top of her? Basically, who's at a higher position? The manager, right? You guys, when you work at a job or something, basically you receive tasks and such from your manager, right? So the API is basically the manager behind the desk, and the database is your storage room. Okay, so you as a user, you interact with the client. The client sends a request to the API. The API processes that request, applies logic, etc., validates the input as well. You need to make sure you have an input, okay? And if it was needed, it talks to the database, and then the database responds. You get a response from the database. The API formats the result, and then it sends it back to the client. So basically, an API is like the middleman, or you can say like a bridge and such. Okay? I hope that answered your question, Zero. Okay, there is another question. So Mariam is asking, my question was, okay, so if thousands users trying to read from one primary DB, it could be overwhelming, but when we create replicas, copies of the primary DB, it can make it easier to access the data? Okay, that's a very great question, Mariam. And yeah, exactly. Because let's just say users are trying to read from a single primary database, okay? And it gets overwhelmed, of course. And just a quick fun fact, I think we haven't dove into the database session yet, but databases, they often have limits. You have connection limits, CPU, memory, and such, okay? So in the majority of systems, as we've talked about, okay, the writes go to the primary DB, okay, because your primary DB is the source of truth, and the reads can be distributed, okay, and this is why we've talked about replicas. This is where read replicas come in. Okay, so a replica is basically just a copy of your primary database, and the primary one continuously keeps updating to replicas. So instead of having like 1000 users on 1 DB, okay, you basically get the writes on the primary, and the reads, you have multiple replicas. So what you're doing is you're distributing the traffic, and of course this improves the performance, makes it more fault tolerant in case an issue happens or something, and it makes your system more scalable. Okay? Any further questions, guys? I hope that answered your question, Mariam. I'm really glad, Zero. I'm really glad it's much clearer. Rewatch the stream. Make sure to digest it well, take notes and such. Okay? It's like making copies of a book so everyone can access it easily. Okay, you're most welcome. All right, so I'm gonna take one final question and we're gonna wrap up for today. Okay, Zero. Okay, why do we need DB replicas? Because the data is huge, and I'm lost about the read and write. Read what and from where, and write what depending in whose order, and SRQS, you mean separating read. Okay, so we have a lot of questions here. This is the last question for sure. This is, I think, 4 questions, right? Okay, let me start by the last one. Okay, first of all, it's not SRQS. Let me go back to its slide actually. Okay, it's called CQRS, which stands for Command Query Responsibility Segregation. Okay? This is what it stands for. So, this is answering the first half part of your last question. Now, let me try to answer them all at once and we're gonna wrap up. Okay? A very great question, by the way, and it shows that you're actually, questioning things and grasping things and understanding. So, first of all, we don't create the DB replicas just because the data is huge, okay? That's not the reason why we create it, okay? That's one. We often create those replicas because your traffic is huge. So it's not the data that's huge. No, it's the traffic that's huge. Okay? And there's a difference between those. Okay? You can have small data, okay, but thousands and millions of read requests per second. And this often, it overwhelms and overloads a database. Okay, so this is to answer your first question. All right. Now, for the second part, who reads and who writes? So basically, in a primary replica setup, the writes go to the primary database, and most of the reads they go to the replicas. Okay. As we've mentioned, the primary is the source of truth. It handles the insert operations, the update operations, the delete operations. If you're not familiar with SQL, insert means just adding stuff. So what happens is the replicas receive continuous stream of updates from the primary, just to ensure that the two of them are basically synchronized. Okay, and what determines where we read from? It basically depends on your consistency requirements. So, for example, let me explain it via an example. Perhaps it will be much clearer. Let's say I posted a comment, okay? When you're commenting on someone's post on LinkedIn or Instagram, you need to see it immediately, right? So, in this case, okay, we need to read from the primary. But what if you're shopping on Shein? You sometimes notice it's not as fast in displaying products or such. I don't know if you guys noticed that before, perhaps. But let's say you're browsing, product listings. Okay, so in this case, you can read from the replicas. All right. And regarding separating the read and write, what we're just talked about and what we're mentioning, and very great question, is basically called read-write separation. So this is essentially called the read and write separation. We are separating them. And often, how we separate them, basically your application layer decides that. So you just define if the request is write, send to primary, or if the request is, let's say, read, okay, it sends to the replica one. All right. And this is often controlled by your DB routing logic. You're going to be seeing more of that hands-on on Sunday. And perhaps I think tomorrow as well. Okay? So there is something called routing logic and such. And regarding the CQRS, I think I've already talked about it. I hope that summed up the answers to your questions, Zero, for your four questions actually. If you have any further questions, guys, feel free to reach out on LinkedIn actually, scan my QR code, and you can just reach out and such. We were doing a couple of mentoring sessions, but right now they're on pause, like at Code Vasera, but we're gonna be bringing those back real soon, probably in May. So we'll be announcing details for sure, okay? Feel free to add me on LinkedIn if you guys have any questions, and those are the socials for Code Vasera and such, okay? Thank you, Ahmed. I'm glad you guys have enjoyed. So I think this wraps up our session. Have a great evening, everyone. Feel free to reach out in case of any questions and such. And as promised, we're gonna tackle part 2 of today's session on Sunday. It's very exciting, a lot of information to digest for sure, but it is extremely important and it is real fun and real great. We're not just writing code anymore, we're diving into all of those critical aspects. So make sure to digest it real well, okay? All right, so have a great evening, everyone. I'll see you on Sunday.